If you are a blockchain developer, listen carefully, because in this video I will show you how to create a simple multiplayer NFT game. So as you can see, I have my Aavegotchis here. I move this guy right here and it moves in all other screens. And these are real Aavegotchis. As you can see, if I go to my Aavegotchi account, I have this guy right here and it is the same picture that I have right here. So when I log in, the game recognizes which NFT I have and then I move it around and it's correct. Everywhere it moves, it's updated in real time. And here I have this Aavegotchi, and as you can see, I move it right here and it moves everywhere else. The most important thing about this program is that it's very short. Look here, the whole program for the server to make this work is just 119 lines of code. And then we have this API right here, but you don't have to worry about it. It's not really part of the main server logic. This is the main server logic, just 119 lines of code. And most importantly, this game ensures that you cannot cheat. You cannot try to hack the front end. You cannot try to hack the website so that the website itself can move the character somewhere else. The only thing that the front end can do is to ask if the front end can move left, right, up or down. That's it. And then server decides, is that move allowed or not? So all game logic is really on the back end. The front end only asks, hey, please server, can I move here? Okay, perfect, I move here. So server is in control. This means that you cannot cheat. There is no such thing as cheating, because as you know, in NFT game, if somebody cheats, it can mean that they win real prizes. It can mean that they win real tokens. It means that they win real NFTs. And so this is exactly what I will show to you today. And this is the example of an Aavegotchi minigame. But of course, this kind of code, this kind of logic, this kind of software can be used for any game. If you have your own game that has nothing to do with Aavegotchi, perfect. You can use this infrastructure and this 100 lines of code as well. If you have Aavegotchi ideas, because this is really my idea for this came when I spoke to Aavegotchi team and they discussed that there is these mini games in Aavegotchi. And here is where I thought, okay, let me create a minigame. Let me create something like a boilerplate for a minigame on Aavegotchi. So this is what we're looking at. So if that is interesting to you, if that sounds exciting, smash the like, destroy the like, comment something, write something, subscribe, and let's get started. And the first question I get is, of course, how can you make something this amazing, something this complex, real-time communication, graphics, real-time socket communication with just 100 lines of code? And here's where you need to have the correct tools. For this, we're using Moralis, the ultimate Web3 development platform, because Moralis has all of these simple use cases that all dapps need already figured out and is basically served to you on a silver plate. For example, real-time alerts is very important for an online game, that you have real-time communication. NFT balances, very important for an NFT game, because when you log in, you remember that the game knew which NFTs I had from scratch without me doing anything. So this is what we will be using, and this is very, very easy to do, because the only thing you have to do in order to log in a user is the following. I will show you here in the code. And by the way, front-end code is also like 100 lines of code. But the first thing we do is to import the Moralis SDK, Moralis JavaScript. Then we initialize it with the server data, and you can find all your servers. When you log into Moralis, you go to servers, you create a server here, and then if you go to view details, you find all of this information. And so next you can initialize it like this. And this is on the front end. And this is, by the way, not any sensitive data. The only sensitive data in Moralis server is this master key. So this is sensitive data. But the API key and the Moralis server URL, this is not, the application ID and server URL are not sensitive data. So you put it here in the front end. To log in, very simple, one line of code. That's it. So when the user comes to the page and they want to log in, this is what you run, and this is it. And why is it so amazing? Because as soon as the user logs in, I can show you in the database right here. As soon as the user logs in, you get the user in Moralis database here. As you can see, I have the accounts, I have their ETH addresses, I have everything. But most importantly, I have their NFTs instantly. I don't have to do anything. I just log in the user and I have their NFTs instantly in Moralis database. I mean, one line of code to log in user and get NFTs, that's insane. And that is why we can accomplish these insane things with just 100 lines of code. Because at the end of the day, crypto right now lacks great tools. And Moralis is a tool that really accelerates this whole crypto industry by 100x, because you can build so many new use cases, so many new dapps with few lines of code, and you can focus on what actually matters, which is adoption. Right now we don't have a lot of adoption, so this is very important. But anyway, you log in user, you get all of their NFTs, one line of code. Next, as you can see, I set up the drawing of the game, and we're using a library called Phaser. It's a game library, and it's very good for these simple things. You can draw something like this very easy. So here we're just initializing the Phaser library, and then each game has a so-called life cycle. So the game starts by loading a bunch of things. So in this case, we have the function preload, and here I load the background, and I start pinging the server. So this is important. I start pinging the server. And because the server needs to know which clients are active, which players are right now active in the game. So we start pinging, and this ping function, it repeats. So let me see if I can find it. Ping. Yeah, here. As you can see, it pings the server, and then it queues another ping in 1 second. So we ping the server each and every second. And I will soon show you the server side, but let me first show you the client side. So I preload an image right here. I don't preload anything else because I don't know which image the users will have. As you know, the image for the user is fetched from the blockchain. This is when I log in with MetaMask, only then can the game fetch my image because it's on the blockchain. It's an NFT. So I cannot load anything more than just the background image. I set up the keys, basically that when I click WASD, I move. Then I set up this subscription to the game state. What is this? I will show you. If I go to my database in Moralis, you see that I have game state. Game state is basically where all players are on the map. All right. And what I do in my front end is that I just set up a subscription that whenever something changes in the game state, whenever somebody moves and it is reflected in the database, I get an alert. So instead of building this complicated infrastructure with sockets, connecting to socket, waiting to open connection, close connection, receiving data, parsing data, I don't care about any of that with Moralis, because Moralis is true Web3 magic. The only thing I need with Moralis to get updates to the game state is subscription, and then subscription.on updates, and that's it. I mean, that's it. So this is 5 lines of code that ensure that my game knows the position of all other Aavegotchis, and that's it. And then what do? We have the update function. This function will run every basically 60 times per second. This function will run, and the only thing it does is listens to keys. Is the W pressed? If W is pressed, send the request to move my character to the server. That's it. When W is pressed, we're not instantly moving the character on the screen because we need to check with the server. Can we actually move? So here is where cheating is prohibited. You cannot cheat in this game. You cannot move your character without actually playing the game and by getting approval of the server. So we do it with up, left, down, right. That's it. And then we have a function for drawing the state. Here is where, if a player is completely new, we haven't seen the player before, we fetch their SVG from the server, and server knows the SVG from the blockchain. I will soon show you, and we basically display the player, and if the player is already here, we just move him around like so. And that's it, guys. That's the whole front end. That's it. Very simple. Basically, the only thing that front end is doing is that it's number one, listening to the keystrokes, up, down, left, right, it sends it to the server, and then it subscribes to the game state. Because the server, when people are sending up, down, left, right, the server updates the game state, and then everyone who is subscribed to the updates, like I showed you here, everyone who has this subscription in their front end, they will get the updates. I mean, this is how simple it is on the front end. Let me show you backend. It's even simpler. I mean, this one is it's basically the simplest game backend I've ever seen. But you have the move function. Let me see right here. So this is the function that the front end can call. And as you can see, the only thing I do is that I get the direction and I update the state. In the function update state, which is right here, I just move it by 5 units in either direction. But here is where I also can add extra logic to prevent movement. Let's say that the map has obstacles. Well, here I need to check, is this player trying to go to some place in some direction where there is an obstacle on the map? The server can check that, and the server can reject the move. So here is where you would add all of these restrictions. Here is where the server would also check if there is some kind of item. Maybe I can pick up an item. Maybe I can do something else. So here's where you would put that, but very simple. You see, I mean, a middle school kid who has a bit of JavaScript knowledge can program this game. So this is a very important update state. And another important function is persist state. Here's where we just save the game state to the database. And when this is done, when we save the state to the database, all clients, all frontends will be updated. I mean, this is how the communication between server and clients work here in real time. If you save something on the server, it's instantly reflected on the client. It's so simple. It's less than 10 lines. Look here. This is less than 10 lines of code together. I mean, basically this one line of code, and here, what is it? 8 lines of code, 6 lines of code to get communication between client and server in real time. Very easy. And then there is a ping function. We just check when the user pinged and we save it to the state. But also here is where we get the SVG from the blockchain, and we basically query the NFT owners. First and foremost, I need to know which NFTs the user has. So I check here in the database which NFTs the particular user has. And then based on that, I go to the blockchain and I fetch their SVGs. And SVG is fetched in this function that looks scary, but you know, it's very simple. It is just this ABI that is absolutely massive, but this is just copy paste. You copy paste this from Aavegotchi contract, and then the only thing it does is just calls get SVG, and that's it. It's very, very simple, guys. So this is the game that we created with Aavegotchi. There are some improvements. So look, if you're watching this and you want to improve it a bit, you can do it. So for one, when I click to move, there is a bit of a delay. As you can see, it's not completely instant because the server needs to approve the move, okay? Before I move the character on the screen, I have to wait for the server to reply that the move is okay. And of course, it can take 200 milliseconds, 500 milliseconds. So one improvement you can make instantly, and this is on client side, is that as soon as we move the key, we move the character. Because when that happens, you see that it's already there. Let's actually see it in real time. Because if you move in real time and you try to cheat, it will still be cancelled by the server. But you can predict, on the front end, you can still predict where the character will end up. So let's see, if I move, let's try it with moving to the left, to the right. Let's see, move right. So let's see if this is smoother. If I put it right here, and I'm just experimenting in real time here. Let's see, I refresh, bam, I move to the right. Yeah, it is a bit smoother. This is already a bit smoother. I would actually recommend putting all of the moves in, also in the key functions. It was already smoother, but there is some work to do on how smooth the client is. Because in all online games, you have a lot of work to do on predicting what the server will do. So this is a bit of extra material for you to study. The way we ensure that nobody cheats is by saying that, hey, you cannot move. So the player wants to move, but look, we cannot move without, let's see, zoom out. The player wants to move, but first we check with the server. Does the server allow movement? And then the server comes back to the client. So the client is here. The client wants to move. We check with the server, and then it needs to come back. So here's where we can lose 200 milliseconds. And this removes the feeling of smoothness a lot. Instead, what the client can do is that as soon as the player hits move, some kind of key where the character moves, the client already moves on screen, all right? And then it waits for the server to just confirm that this movement was actually valid. But the client can do a lot of smart things where it predicts, you know, what the server will reply. And if the server says, hey, by the way, this move was invalid, well, then you can just move the character back. But this rarely happens, you know. In most cases, the client can very accurately predict where the server will put the player next. So this is some improvement, but all in all, guys, I leave the code for you in the description. Go check it out. You can already now start building your own NFT games online, multiplayer. Maybe you build the next World of Warcraft. Maybe you build the World of Warcraft of crypto. Who knows? Anyway, smash the like, leave something in the comment section, and goodbye, guys. Goodbye.